Hi everyone and welcome back to physics. This is Mrs. Hutchinson and today we're going to continue our discussion on motion, but we're really going to get into some practice problems between motion and velocity. Our previous video we talked a little bit about velocity itself. We also talked about what I expect of you every time we do a calculation in terms of the given wanted equation, substitution, and our answer sections. Also, you need your units whenever you're looking at any of these types of problems. So let's get into it. Before we get into actually looking at the questions themselves, if you do not have your reference table out and flip to the mechanics section, please make sure that you do that. Remember, you can find our velocity equation, this one here, in our mechanics section of our reference tables. It's the last page, page 6. And in case you forgot, D could stand for displacement or distance. Displacement, remember, that would be our vector quantity. Remember, vectors have both direction and magnitude. Magnitude is just the number. And distance is our scalar quantity, which simply has magnitude. T stands for time, and V could be velocity or speed. So again, speed is a scalar quantity, and velocity is a vector quantity. So velocity would mean something like 65 miles per hour north. Okay, where speed would just be our 65 miles per hour. Just a little refresher on those. So now, let's take a look at our guided practice. Okay, let's do purple. So, on May 28, 2000, Juan Montoya, just so you know, became the first Colombian citizen to win the Indianapolis 500. Montoya completed the race in a time of 2.98 hours. What was Montoya's average speed during the 500-mile race? All right, so again, you might be able to do this just by simply looking at it, but please, please, please don't do that. Take your time. Let's write our givens. So we've got our time is equal to 2.98 hours. We've got our distance, 500 miles. Now, let's look at what we're trying to find, our wanted average speed. So now let's write our equation. So what equation are we going to use? Well, we only really know one equation at this particular point, so it's not that bad. But we want our equation to incorporate all of the variables. The variable that we're looking to solve for, as well as the variables that are given to us in our question. So let's substitute things in. Please, please, please substitute with units. So we've got our 500 miles over 2.98 hours. And our answer, we do this calculation correctly, plug it into our calculator, we would get 167.8 miles per hour. Again, if you didn't put your unit with that, please make sure that you put your unit on your final answer and that you put your units in your substitution. That wasn't so bad. Hopefully it was a nice refresher for us. What I want you to do now is pause the video, try question number 2. Again, like I said, because this equation is so simple, I don't want you to just skip to solving for this particular question and solving directly for the answer. Please make sure you do your given, your wanted, your equation, your substitution, and your answer, all with units. So pause the video and try question number 2 now. Hopefully you pause the video and you solve for question number 2. I'm going to go over the answers to this. I'm going to show you what your setup should look like. The slowest animal ever discovered was a crab found in the Red Sea. It traveled an average speed of 5.7 kilometers per year. It's a pretty slow little crab. How long would it take the crab to travel 100 kilometers? So, let's write our givens. Got our average velocity or average speed of 5.7 kilometers per hour. Our distance is 100 kilometers. Okay. Let's take a look at our wanted. Our wanted is how long. So, that would be our time. Our equation that we're going to use is the one that we've been using all along. V equals d over t. So let's substitute in. Please, please, please substitute with units. I don't know how many times I can say it. Okay. So we plug in what we know. If you don't know how to solve this particular type of equation, you cross multiply and then you'll divide. So I'm only going to show you this once because it's assumed that you know how to solve a mathematical equation like this. If you do not, I suggest you brush up on your math. So our answer for our time was this poor little crab. It would take him 17.5 years to go 100 kilometers. Poor little guy moves really slow. Hopefully that's what you got. If you didn't get that, so if you didn't solve for that, pause the video, see what you did. Maybe you plugged something into your calculator wrong. If not, if this is what you got, I want you to pause the video and try question number 3. Hopefully you paused the video, tried question number 3, so let's go over this one. It says, Benjamin watches a thunderstorm from his apartment window. He sees the flash of a lightning bolt and begins counting the seconds until he hears the clap of thunder. 10 seconds later. Assume that the speed of sound is 340 meters per second in air. How far away was the lightning bolt in meters, and how far in kilometers? So we've got 2 things that we're going to be solving for here. So we do have to do a conversion. Let's write down what our givens are. First, we've got our time, 10 seconds. We've got our speed, which is 340 meters per second. We now have our wanted. So for part A, we want to figure out our distance in meters. And for part B, we want to find out our distance in kilometers. So our equation that we're going to use is going to be the same for both parts here. V equals d over t. Not too shabby. Now let's do our substitution with our units. So 340 meters per second equals distance over 10 seconds. Our answer, hopefully you can do that math, would be, hopefully you also don't need a calculator, 3,400 meters. So this is our answer for part A. Part B, hopefully you remember how to convert from one unit to another. If you don't, go ahead and check out that video or take a look back at that particular video. So we've got 3,400 meters. We've got 10 to the third meters, 1 kilometer. These should cross off, multiplying straight across. So we get 3.4 kilometers. If you forgot how to do a conversion like that, you can pause this video, go ahead and take a look back at our conversion video. Sorry, pardon me. Now what I want you to do is take a look at the next question. So try that one on your own. Pause the video, try it on your own. Once you've completed it, I want you to replay the video and we'll start over. Question numero 4, which is the technical term for 4. An airplane travels at constant speed relative to the ground of 900 kilometers per hour. How far has the airplane traveled after 2 hours in the air? How long does it take the plane to travel between two cities that are 3,240 kilometers apart? If the second plane leaves an hour after the first and travels 1,200 kilometers per hour, which flight will arrive at the destination city first? So this is kind of a loaded question. There's a lot involved with this. We're going to take this one step at a time. Okay. So let's go over for part A. So A, we've got our given. Given is that our velocity is 900 kilometers per hour. Our time in this instance is 2 hours. What we're trying to find, what we want to find in this instance is our distance. So now let's use our equation, the one that we have been using. V equals d over t. So let's substitute everything in with our units. Get 900 kilometers per hour equals distance over 2 hours. So if we solve for this particular portion, part A, not so bad. Our distance should be 1,800 kilometers. Again, you just simply cross multiply. So that's our answer for part A. That shouldn't be too terribly difficult. If you struggled with that, pause the video, take a look at what I wrote, take a look at what you wrote, and find your error. If you got it, let's move on to part B. So I'm going to erase everything in here, and let's do part B. It says, how long does it take for the airplane to travel between two cities that are 3,240 kilometers apart? So let's go over what our givens are for part B. So our velocity is still 900 kilometers per hour. But now, instead of time, we're given distance of 3,240 kilometers. What they're asking us now for part B is how long it's going to take that particular plane to travel that distance. So they want us to solve for our time. Let's use our same equation that we have been using, V equals d over t. Substituting with units as always, so 900 kilometers per hour equals 3,240 kilometers over our time. And we will solve. And you should have time equals 3.6 hours. That's not so bad. That wasn't too terribly difficult of a question. Hopefully you got that answer. If you didn't, pause the video, check my work, see what you did. Don't forget, solving for this in the substitution, that is something that you should definitely be able to do. If you got this, let's move on to part C. I'm going to erase everything. So let's do part C here. If a second plane leaves an hour after the first and travels 1,200 kilometers per hour, which flight will arrive at the destination city first? All right, so this is part C, we've got a lot of givens here. So the velocity of our first plane, 900 kilometers per hour. We're also given the velocity of our second plane at 1,200 kilometers per hour. We are also given our distance of 3240 kilometers. Because that's what they're talking about, the destination city. Between two cities, they're talking about that distance there. So, what they're trying to ask us is which one's going to arrive at the destination city first. In other words, what they're asking us to find is time. So, time for our first flight to reach the destination city and time for our second flight to reach the destination city. The equation, same one we've been using, v equals d over t. Best part is we've already actually solved for our first time. So all I'm going to do is solve for the second time, for our second velocity. So we've got 1,200 kilometers per hour equals 3240 kilometers over t2. In solving for that, we would get t2 equals 2.7 hours. So what this is saying is that our second plane takes 2.7 hours, and I'm just going to write our final answers down here at the bottom. So our second plane takes 2.7 hours to reach its destination. And our first plane, if you recall from part B, took 3.6 hours to reach our destination. However, they're asking if the second plane leaves an hour after the first. So we have to add an hour to our time for our second plane. Which one's going to reach the destination first? Well, looking at the time differences, our answer would be our first plane. They're not asking which one's going to get there the fastest. They're simply asking us which one's going to arrive first based on the time intervals with which they leave. So make sure that you're answering the question that is being asked. I'm sure many of you got the appropriate time. You just probably forgot to add the 1 hour to it. If you got this wrong. If you got it right, kudos to you. And what I want you to do now is move on and try question number 5 on your own. If you didn't understand question number 4, rewind the video, listen to it again, and I'm sure it'll help. So, question 5. You and your friend start jogging around a 2.00 times 10 to the third meter running track at the same time. Your average running speed is 3.15 meters per second. Your friend runs at 3.36 meters per second. How long does your friend wait for you at the finish line? So unfortunately, you are the slower of the two. That's always me, so don't feel so bad. It's not, you're just taking in the scenery, really, in my opinion. So let's go ahead and let's figure out what our givens are and what they're asking us to solve for. Might be in a convoluted kind of way. So our given, we've got our distance. So I'm just going to convert 2 times 10 to the third into standard notation. So 2,000 meters. We've got your velocity of 3.15 meters per second. And we've got your friend's velocity of 3.36 meters per second. Okay. Wanted. Well, they're saying how long does your friend wait for you at the finish line? In other words, this is a very weird way of saying they want you to solve for your time and your friend's time, and then simply take the difference between those two times. So that may be a little tricky for some people to figure out, but they're just asking for the time in which it took you to complete the lap and the time it took your friend to complete the lap, and then just simply ask you to solve for the difference between the two. So being able to identify that, make sure that you really read the question appropriately. Our equation, same one we've been using, V equals D over T. Let's substitute it in. So we're going to have two separate substitutions here. So we're going to substitute for 1 and substitute for 2. So we've got 3.15. Please make sure you still have your units. Equals 2,000 meters. Okay. And then 3.36 meters per second equals 2,000 meters over time. We solve for our answer here, solve for our answer here. So your T1 and T2 over there. So T1 is 635 seconds. That's your time. T2 is 595 seconds. That's your friend's time. So if you had to solve for how long your friend had to wait, so in our final answer here, we would simply take the difference between your time and your friend's time. So we would get 635 seconds minus 595 seconds. And hopefully you came up with your friend had to wait 40 seconds for you and your slow butt to make it across the finish line, which I will tell you right now, you know, them waiting is not such a bad thing. It's really not. It's okay. Hopefully you got that right. If you had any questions on that, it probably was where to really start in this particular question, but once you got started, it wasn't so big of a deal. Not too bad. Okay. If you had a question on that, or if you got anything wrong, you can rewind the video and watch it again. If you got it right, well, then we can move on. So, what we're going to do now is our independent practice in motion and velocity. Now, I want to read the question first. You're going to try all of these on your own, but I'm going to give you a pretty big hint for these. So, Hans stands at the rim of the Grand Canyon and yodels down to the bottom. He hears his yodel echo back from the canyon floor 5.2 seconds later. Assume that the speed of sound in air is 340 meters per second. How deep is the canyon at this location? Okay. Well, I'm not going to write down your givens. I'm not going to write down any of that sort of thing. But what I am going to tell you and show you is the world's worst drawing of the Grand Canyon. There's the Grand Canyon. Here's Hans. Right there. I feel like Hans would have long hair. So let's give him some long hair. Okay. So there's Hans. He yells. His voice travels down and it travels back up. The question is, how deep is the canyon? So my question to you is, how long does it take Hans's yodel to reach the bottom? So really think about that. Does it take our full 5.2 seconds? Or is it a different time? So really, really, really think about that. How deep means our distance. So think about it logically. If it takes him 5.25 seconds to hear his yodel come back up, how long did it just take to travel down to the bottom of the canyon? Okay. If you can't figure it out, ask a neighbor next to you. If you can, go ahead and try all of these questions. And I will see you for our next video.